Alright guys, we're going to be going over lesson 22, which is writing and evaluating expressions. And this time we're going to be going over exponents. So a lot of these we're just going to go over the exponents, but we're not going to calculate it out because sometimes we get down to where it's like, let me look at one. It gives us like 2 to the 14th power and on 2 to the 47th power. So we're just going to write the exponents, but we're not going to actually calculate them out, since you all know that we do not use calculators in here because calculators are not able to be used on the FSA. So we're just, some of these we will be skipping over, but we will be doing the ones that we can. So go ahead and look at the first one. It says example 1, folding paper. Alright, number 1 says predict how many times you can fold a piece of paper in half. We write a prediction down. Any prediction, don't look at someone's paper or anything. This is nothing that's going to be wrong or right. It's just writing down the prediction. Alright, quickly, just write down the prediction. Alright, number 2 says before folding, or before any folding, 0 folds, there is only 1 layer of paper. This is recorded in the first row. So in the first row, it says 0, and number of paper layers that result, we saw the full page, and it says the number of paper layers written as a power of 2. So this is 2 to the 0th power. So it's just 2 because it has not been folded yet. Alright, then the next layer, the next row says number 1, then you have number 2, and number 3. And some of these you won't be able to do. Some you can. Actually, this one wouldn't be too hard. So I want you actually to try to do these, because this one doesn't even go to 300. So you will be able to do this. You just got to multiply these by 2 over and over. Alright, so it goes all the way. I'll do a few of these and I'm going to let you guys do the others. Alright, so number of folds, the first one was 0, and then for the number of paper layers we have 1, and then for the exponents we had 2 to the 0th power. So the next one, you'll just go in order. 1 would be 2 folds, and that would be 2 to the 1st power. Alright, 2 folds would make the paper result in the number of layers. There would be 4, because if you actually take it, if you have scrap paper, do not use my paper. If you have an extra piece of paper, go ahead and do this. Don't take my paper to do this activity. You could take a piece of paper that is old in your binder. Find a piece of paper from a friend if you want. You do not get my paper for this. Let me make that clear. I'm not giving you paper to do this activity. You'll have to figure it out if you have not brought paper yourself. I give you guys paper to use for writing down exit tickets and activities and everything else, but I'm not giving it to you just to fold it up. Alright, because most of you are just going to try to play with it anyways. Alright, so the number of layers that would result in 2 folds would actually be 4. So if you was folding your paper, you would see the layers, number of paper layers that result from 2 folds would be 4. Alright, and then that would be 2 to the 2nd power. So I'm going to give you a hint. This row goes in order, and so does this row. So 2 to the 2nd power is here, so my next one's going to be 2 to the 3rd. These are the ones that's going to change for the number of layers. So I'll tell you 3 folds. If you folded your paper 3 times, you would have, or if you folded your paper 3 times, you would have 8 layers. Alright, then I want you to try to figure out. And if you didn't know that, you could say 2 times 2 times 2, because that's 2 to the 3rd power. Alright, sorry, that's a weird thing there. Alright, so 2 times 2 is 4. Well, 4 times 2 equals 8. And that's what we got right here. So 4, so I said this was in order, so you'd have 2 to the 4th power. So you do 2 times 2 times 2 times 2. So this is why another reason why you really don't need paper and will not use mine, because all you have to do is complete these. So you do 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And that's all you have to do. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. You just follow along. So the next one, 2 to the 5th power, you do 2 times 2 times 2 times 2 times 2. You do it 5 times. And you're going to keep going. So you'll have 2 to the 6th power, 2 to the 7th power, and 2 to the 8th power. So you just multiply 2 by the number of exponents you have to get these answers here. And I want you to do it yourself. So hurry up and fill in those exponents. Look at what I did, and you will be figuring out for these answers. It's not hard. All you're doing is multiplying by 2. So I'm going to give it to you. Alright, I'll leave this up while I read part A. And this, number 2, it says, are you able to continue folding the paper indefinitely? Alright, what does indefinitely mean first? Indefinitely is an infinite amount of numbers, like you just keep on folding it. Will you be able to keep folding it forever? No. You don't have to get a piece of paper and start folding it to figure that one out. Obviously, you're not. The stack is going to get too thick because on one corner it keeps doubling each time. So you're not going to be able to. At a certain point, because I know all of you probably have tried this in elementary school, you cannot keep folding a paper indefinitely. So your answer there is no. It's going to get too thick. You won't be able to continue folding it. All right, B says, how can you use a calculator to find the next number in the series? All right, the next number in the series would be 9. All right, we got to our last number on here was 8 folds, so it would be 9 folds, which would be 2 to the 9th power, and you would just multiply it to 9 times. 3, 4, 5, 6, 7, 8, 9. And then you just keep multiplying. 2 times 2 is 4. 4 times 2 is 8. And you would keep on multiplying each of those numbers by 2. So that's what you would write. You can multiply, it would be 9 folds, and it'd be 2 to 9th power, meaning that you would just multiply 2 times 2 9 times. All right, flip your page over. It says, what is the relationship between the number of folds and the number of layers? All right. As you could see, these are the number of layers and the number of folds. If you look back at your table, because I showed you the number of folds and the number of layers. All right, look at it. And look at the relationship you see. Every time you fold it, what happens to the number of layers? Does it increase? Does it stay the same? Or does it decrease? You tell me on that one. All right, D says, how is this relationship represented in exponent forms of the numerical expression? Okay, you would use, what is our base number that we use for our exponents? You notice every base number was 2. And then the folds was the number of exponents. So if it was, so 2 is our base. So if we had 3 folds, if we had, let's say 3 folds, it'd be 2 to the 3rd power. So the folds is the exponents, and 2 was our base number. So that's what you should have for C, or sorry, D. All right, E says if you fold a paper F times, so that's a variable they're giving us, F. All right, write an expression to show the number of paper layers. So our paper layers, and if it's folded F times, that would mean it was, what would our exponents be? I'm going to erase this. It would be 2 to the F power, which would be in the 3rd box. I'm going to erase this from the last one. So in the middle, what would it be for how many it says how many layers. You would have to calculate this out for how many layers. Okay, so remember that'd be 2, it'd still be the same thing, it'd just be calculated out. Alright, because this is the same thing as this. It's just calculated out. You'd have to It'd be really 2 to the f power since we don't know how many folds it is. So really it'd be the same thing, and then it'd be the same exponent. All right, let's look at number 3. So this was your answer there. Make sure you fill that in. It'd be 2 to the f power for the second and third box. Since we don't know what f is, how many folds there are, there would be 2 to the f power layers of paper. All right, moving on to 3. 3 says if the paper were to be cut instead of folded, the height of the stack would double at each successive stage, and it would be possible to continue. All right, write an expression that describes how many layers of paper would result from 16 cuts. 16 cuts would be 2, so we'd have 16. Now it's cuts instead of folds. So it'd kind of be the same, 2 to the 16th power. And that's it. And then we'd have to come this for B. So B says evaluate this expression, 2 to the 16th power. I'm not going to make you multiply 2 16 times. Okay, multiplying it like 8 times, that even go to 300. But this one would be 65,536. So here's your answer for B. You need to write 2 to the 16th power equals 65,536. And again, I'm giving you, because you guys do not use calculators in this classroom, and you know that with FSA. All right, so go ahead and put that down because I gave it to you. You're just to write it down. All right, look at example 2. It says bacterial infection. Bacteria are microscopic, single-celled organisms that reproduce in a couple of different ways. One in which is called binary fission. Binary fission, in binary fission, a bacterium increases its size until it is large enough to split into 2 parts that are identical. These 2 groups until they are both large enough to split into 2 individual bacteria. This continues as long as growing conditions are favorable. Alright, so let's look at the next page. A says record the number of bacteria that results from each generation. So it already starts your table. So look at that table. It says 1 generation. The number of bacteria is going to be 2. And the number of bacteria written at, as a power of 2. So once again, our base would be 2. Would be 2 to the first power. Then it gave you the second generation. The second generation would be 4. It gave you the number of bacteria, which is 4. And that is 2 to the second power, because 2 to the second power is 2 times 2, and that equals 4. So really you need to do your exponents first, get that answer before you do the other ones. There will be from, I don't want you guys to do 9 through 14. I want you to give me the exponents, but not the answers. I'm going to give you the answers on that one, on those. So really all you need to do now is go straight down and do your exponents. You have 2 to the first power, 2 to the second power, 2 to the third power. Next will be 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, 2 to the seventh power, 2 to the eighth power. And then I'm going to show y'all 2 to the ninth, 2 to the 10th, because I'm going to give you guys the answers for those, because that is too much to try to figure out. Actually, no, I'm not giving you guys 2 to the 9th. You guys could do that. I'll give you 2 to the 10th, 2 to the 11th, 2 to the 12th. Actually, you know what? Some of these are just doubling them. In fact, they all are. So once you get, if you notice here, they are all doubling your numbers in the middle. So I'm not going to give you guys any of it. You guys are going to figure this out. Go ahead and write your exponents in order. It already gave you 2 to the third power, 2 to the second, 2 to the first. So go ahead and finish fill it in all the way to 2 to the 14th power. So it starts with 2, 4, 8, and then it leaves it blank. So 2 doubled would be 4, which is 2 to the second power as well. 4 doubled is 8. Well, that's also 2 to the third power, which is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that just doubled it. So now 2 to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Now watch this. What is 8 doubled? That is 16. All right, now I'm going to give you one more, and you're going to figure this out yourself. But all of these are just doubling these middle numbers here. All right, and then this is just going in order. 2 to the fifth power, 2 to the sixth, and that's in order. All right, 2 to the fifth power is 2 times 2 times 2 times 2 times 2. All right, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Well, guess what this is in the middle? 32. And 16 doubled is 32. So you're going to keep doubling these numbers, and this is just going to be in order. So you don't even have to do any multiplication like this, as long as you know how to double. What is 32 doubled? Your next one will be 64. Then you do 64 doubled and get that answer. And then you get that answer, double it for the next answer. So keep doubling it for the answer number. We're working out on. You guys should be able to do all of it. It is simple. All right, B says, how many generations would it take until there was over 1 million bacterial presence? Okay, this one, I'm going to give it to you. It's going to be 20 generations, because that one would get a little hard. You'd have to keep doubling all that until you got to 20, and it only ends at 14. So I'm going to give you that. It's 20 generations. So write 20 generations for that one. Because that's going to give you just a little over 1 million bacteria presence. All right, look at C. C says, under the right growing conditions, many bacteria can produce every 15 minutes. Under these circumstances, how long would it take for one bacterium to reproduce itself into more than 1 million bacteria? Okay, so if you look at all of these and you went in order on the tables from generations 1, 2, 3, and all the way down, it gives us 14. So this is all 15 minutes. It took 15 minutes to grow the first one. All right, and another 15 minutes would have been 30. Another 15 minutes would have been 45. 40 takes 15 minutes. So how many 15 minutes? Well, really, if I just gave you the answer, because all you need to do is say how many 15 minutes. So this was, so actually you could just say this is 1 15 minute, this is 2 15 minutes, this is 3 15 minutes. Instead of going in order, I'm going to make it easier for you guys. So I already gave you, it was 20 generations. So how many 15 minutes is that? Look, this is 3 15 minutes for 3 generations. So if it's 20 generations, that's how many 15 minutes? Very easy. It gives you the answer. And I gave you the answer for the generations for B. All right, look at D. It says, write an expression for how many bacteria would be present after G generations. All right, we don't know the amount of generations. We'd say 2 to the G power. It was like our other one that we used where we put, what was the variable we used? F layers of paper. If we didn't know the papers, we put 2 to the F power. And this would be the same. It'd be 2 to the G power, and our exponent would be 2 to the G power, because we do not know these numbers. So since we don't know how many generations. So there would be 2 to the G power of bacteria present after G generations. Alright, let's go to the next page. Filling that in. Give y'all just a second. And then start looking at that cube for me. Sorry guys. Look at that cube. Alright, we're going to be talking about length times width times height again. Let me go ahead and erase this. Alright, so example 3 says volume of a rectangular solid. And if you look at the box, it says height equals 2W, means 2 times the width. L equals 3W, meaning 3 times the width. And then you see just W, and that stands for width, obviously. Remember, we have length times width times height for volume. We've already been over this. Alright, so underneath that it says this box has the width W, like I said. The height of the box H is twice the width. That's why it says 2W. Like I said, that means 2 times the width is the height. The length of the box L is 3 times the width. And that's why it says L equals 3W. So whatever the width is, you multiply it by 3. That is, the width, height, and length of a rectangular prisms are the ratio of, and it gives you 1, 2, 3. Because you have the width and then the length, it says the height, is next. The height is 2 times the width. So this is, I'm going to put a W on top of this, width, height, and length. The height is 2 times the width. This was the width, let me erase that. So this is 2 times the width that we started with. This is the length, which is 3 times, I didn't mean to put L, I meant to put W. 3 times the width. And this is the width. Alright, so the width is 1. 1 times 2 is 2, so the height would be 2. And then here's the length. The length is 3W. 3 times 1, which was the width, would be 3. So that is why your ratio is like that. Alright, so for rectangular solids like this, the volume is calculated by multiplying length times width times height. And we've already been through that. Alright, and it gives you, if you look at that, how the volume works. It gives you all of those expressions. Now look at the box at the bottom. It says, follow the above example to calculate the volume of these rectangular solids given the width W. So it's going to give you the width. And all you have to do, like the first one, was 1. Alright, so then you would multiply 1 centimeter times, okay, our height is 2 times the width. So 1 times 2 is 2, so you multiply it by 2. Times our length is 3 times the width, which is 1. So 3 times 1 is 3 centimeters. And that would give us 1 times 2 is 2. 2 times 3 is 6 centimeters. So for your first box, you should have this written. You don't have to put the centimeters. You could put 1 times 2 times 3 equals 6 centimeters cubed, because remember, this is a rectangular solid, so we're cubing it. I would prefer seeing the CMCO node there, but this is your first row. Alright, so the next row, the width is 2, so then you would start off with 2 for your width, and then you would multiply to find the height and length. The height, it should be multiplied by 2, so you'd have 2 centimeters for the width, times 2 times 2 is 4, because our width is 2W, 2 times the width, so there's our width, times 2 times 2, or sorry, 3 times 2, which would be the length, because the length is 3 times the width. 3 times 2 is 6 centimeters. Alright, so that would be our next row, and you need to multiply these together. 4 times 2 is 8. 8 times 6 is 48. And that would be centimeters cubed. So you'll need to be able to do this the same for the rest of the boxes. The last box gives you the variable W. So you'd start with W and you multiply it by the height. And remember, what do you multiply by W to get the height? You're going to put that here. Then you're going to multiply it by the length because you're going to do blank W, whatever you're multiplying the height by. And the same with the length. What do you multiply the length by? It's giving it to you. Go back and look what it gave you. And then you would say equals blank W centimeters cubed. So you'd have something here. How many W's are there? You would count how many did you multiply here? How many did you multiply here? Remember, there's an invisible one there, so you just add how many W's. There should be what you multiplied there. You would add that to this one and to this one. All right, let's go on to the next page. This is the problem set. All right, it says a checkerboard has 64 squares on it. All right, A says if 1 grain of rice is put on the first square, 2 grains of rice on the second square, 4 grains of rice on the third square, 8 grains of rice on the fourth square, and so on, doubling it each time, complete the table to show how many grains of rice are on each square. So all you're doing is putting the exponents, because if it was 2 grains of rice on the second square, that's 2 to the first power. If it was 4 grains on the third, 4 is 2, because our base is 2 to the third power. Because 2 times 2, once again, is 4, times 2 is 8. So 2 to the third power is 8. So really all you're doing is exponents. And you're going to be going just in order. 2 to the third power. 5 is 2 to the fourth power. The checkerboard square 6 would be 2 to the fifth power. The checkerboard square 7 would be 2 to the sixth power. The checkerboard 8, or the checkerboard square 8 would be 2 to the seventh power. The checkerboard square 9 is 2 to the eighth power. Your exponents are just one less than the checkerboard square. So when it says, like the last one says 64 for checkerboard squares, and it says how many grains of white rice, it'd be 2 to the 63rd power. And I don't have to look at any other ones. I just know that my exponent is just one less, because when we started with one checkerboard square, it was 2 to the 0 power. All right, because there's only one grain of rice put on that first square. So that's why the exponents is just one less than the checkerboard square. So you just fill it out just like that. It's really easy, just going right in order, starting with your exponents, 2 to the 0th power for the first one. So you'd have 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and you should end up with 2 to the 63rd power. All right, and then you're going to put an X on B and C. Do not worry about those because we are not using any type of calculators. Look at number 2. You're going to read this. It says that in an investment of money is invested in an annual interest rate of 6%. It doubles every 12 years. If Alejandra invests $500, how long will it take for her investment to reach $2,000, assuming she does not contribute any additional funds? All right, so I want you guys to just try to think about that and figure it out. Remember, this is trying our best. This is the problem set, so these are supposed to be more complicated. Just like if you flip it over and look at number 3, it says the athletics director at Peter's school has created a phone tree that is used to notify team players in the event that a game has to be canceled or rescheduled. The phone tree is initiated when the director calls 2 captains. During the second stage of the phone tree, the captain each calls 2 players. During the third stage of the phone tree, these players each call 2 other players. The phone tree continues until all players have been notified. If there are 50 players on the team, how many stages will it take to notify all the players? So if you need to use like picture diagrams to try to figure that out, do it. because it tells you first stage, second stage, so they keep doubling these, and they tell you they have 50 players in all, so they try to figure out how many stages they will need to do this. All right, do not ask for help. This is just to see how you're going to do. I always go over it in the second video. If you do not get it, it is okay. This is like actually the toughest one of all of them. So you might not get it. It's okay, but I want to see on your paper that you actually tried. Mr. Holcroft is going around to see who's actually trying or who's just sitting there not doing any work. And I am watching you guys. When I don't talk through the monitors, I'm still watching you guys. Sometimes the speaker part is just going out. I am still watching you guys. I'm still documenting everything you guys do. And I'm very disappointed in a lot of you guys that are not following. And I'm still bipping and adding referrals. Some has been processed. Some is good. That's why you'll notice a lot gone. Some is still in the process of being done. They are a little behind, but they are catching up. Your referral will be processed if you've received one. All right, so I would suggest you get under control, because the more referrals you get, the more days you get. All right, so you guys work your best. Do not raise your hand for help. I do not want to see any talking. Stay in your assigned seat. You do not move to any seat just because you feel like it. You have assigned seats for a reason. Remember, I am watching you guys. And I'll talk to you on the next video.